In this video, you're going to learn everything you need to know about Java collections. So by the end of this video, you'll be able to write Java code with confidence. Hi, I'm Mosh and I've taught millions of people how to code through this channel and my online school, codewithmosh.com. This video is part of my ultimate Java mastery course. So once you finish this video, if you want to learn more, you may want to look at the complete course. Now let's jump in and get started. Let's start this section by a brief overview of what we have in the collections framework. So the green boxes you see here are interfaces, and the blue boxes are classes that implement these interfaces. Now don't worry about memorizing any of these. We're going to get back to this slide several times throughout this section. So at the top of this hierarchy, we have the Iterable interface. This interface represents an object that can be used in a for each statement. So if we implement this interface in our generic list class, we'll be able to use it in a for each loop. I will show you how to do that later. Below that, we have the collection interface. This interface extends the Iterable interface and adds additional functionality. It represents an object that can act like a container or a collection of objects. Now here's a question for you. What are the capabilities that we need in a collection? We should be able to add an object to a collection. We should be able to remove an object. We should be able to check for the existence of an object and so on. So these are the operations that the collection interface declares. If you search for Java collection interface, on this page, you can see all the operations that this interface declares. For example, we have add for adding an object, we have add all, we have clear, and so on. Now, below this collection interface, we have three sub-interfaces: list, queue, and set. Each of these, again, inherit all the capability declared in the collection interface and add something extra. For example, the list interface allows us to work with an ordered collection and access objects using their index, just like how we can access an object by its index in an array. Now, we have different implementations of this interface in the collections framework. The one that you would be using most of the time is the ArrayList class, which is an implementation of a dynamic array. So internally, it uses an array to store objects. If the array gets full, it will automatically resize the array. We have another implementation called linked list, which is based on the linked list data structure. The explanation of linked lists goes beyond the scope of this course. I've covered them in detail in my data structures and algorithms course. So we have two different implementations of the list interface. Again, most of the time you would be using the ArrayList class. The queue interface also extends the collection interface and provides additional operations for working with a queue of objects. We use queues in situations where we have a resource that can be shared amongst many consumers. A good example of this is the printer at your office. Different people can print different papers at the same time, but a printer is not going to be able to print them all simultaneously. So each job should go in a queue. The printer will then take these jobs one by one and process them. Now, in the collections framework, the class that implements the queue interface is called priority queue. We're going to look at that later in this section. And finally, we have the set interface, which represents a collection without duplicates. The class that implements this interface is called hashSet. So that was a very basic overview. Throughout this section, we're going to explore each of these building blocks in detail. As I told you in the last video, the Iterable interface is at the top of our hierarchy. Now, more accurately, this interface is not part of the collections framework. In fact, it's part of the java.lang package. So it's one of the fundamental interfaces in Java and represents an object that we can iterate or loop over. Now, before we look at the specifics of this interface, let's talk about the problem it tries to solve. So here in the main method, I'm going to create a generic list, new generic list of strings. Let's add a couple of objects here. So add A and B. Now we want to iterate over this list and print each item. So we write a for each loop. For item in list, look, we have a compilation error here. For each not applicable to type generic list. Now, one way to solve this problem is to go back to the generic list class and make this private field public. Then we'll be able to access the items array from outside of this class. So here in the main method, we can type list.items. Now we can iterate over this array and print each item. Now, the problem with this approach is that we have exposed the internal implementation of this class to the outside. So if we decide to change this implementation in the future and replace this array with a different data structure, all the code that is dependent on this field will have to be changed. As a metaphor, think of the remote control of your TV. This remote control has a few simple buttons for you to work with, but on the inside, it has a complex logic board. That's the implementation detail. Now, if tomorrow the manufacturing company decides to change this internal implementation, you are not going to get affected. If they replace a transistor with an advanced model, you can still use the same buttons you're familiar with. So changing the internal implementation of a remote control should not impact its public interface. In object-oriented programming, we should design our classes in the same way. Again, I talked about this concept a lot in the second part of this series. So back to our generic list, we should not expose the items field to the outside because this is the implementation detail. Let me show you the problem with this code. With this implementation, we can go back to our main method and write code like this. List.items of 0. We set this to a string like A, and then we can print list.items.length. Now, what is the problem here? Well, there is no problem right now, but if tomorrow we decide to replace this array with an ArrayList object, our code is going to break. Let me show you. So we type ArrayList of T. This is a class declared in the collections framework, and it's an implementation of a dynamic array. We're going to look at it soon. So let's create an ArrayList object here. New ArrayList. Now, back to the main method. See what happened? Our code broke because the ArrayList class does not support the square bracket syntax for accessing an object by its index. Also, it doesn't have a field called length. So a simple change in the implementation detail of our generic list resulted in two breaking changes in our main method. Now, this is a very simple program, but in a real application, we could have hundreds of references to our generic list. So if we change the implementation detail, then we will have to go back and fix all those hundreds of places that are broken. So here's the question. How can we iterate over a list without knowing anything about its internal implementation? That is where the iterable interface comes to the rescue. In the next video, I'm going to show you how to solve this problem using the iterable interface. The iterable interface represents an object that is iterable. That means we can iterate or loop over it without knowing anything about its implementation detail. So we are using an array here. If we decide to replace this with an array list or a different data structure in the future, the clients of this class are not going to get affected because they're going to code against the iterable interface. Back to our remote control metaphor, think of the buttons for changing the volume. If the internal implementation of this remote control changes, you're not going to get affected. You're still going to use the same buttons. These buttons are the interfaces that you work with. So we want to implement the iterable interface in this class and then have other classes that use our generic list program against the iterable interface. It's like saying that they use the volume control buttons on a remote control, okay? Now, here's the documentation for the iterable interface. As you can see, this interface declares 3 methods. The first and last methods have a default implementation, so we don't have to implement them. The only method that we have to implement is this method over here, Iterator. It returns an Iterator object. We're going to talk about iterators in the next video, but very briefly, an iterator is an object that we use to iterate over an iterable. Now, I know the name is confusing, but don't worry, I'm going to make it super simple for you. So back to our generic list class. Here we type implements iterable of T. So this is also a generic interface. Now we press Alt and Enter and have IntelliJ implement the methods. So here you can see the same 3 methods that I showed you. The iterator method is highlighted because it's a required method. So let's press OK. And here you can see the iterator method. For now, don't worry about the code we're going to write in this method. We're going to come back and complete this in the next video. All I want you to pay attention to is the return type of this method. It returns an iterator object. So back to our main method. Now that our list implements the iterable interface, we know that it has the iterator method. So we call it to get an iterator. And with this, we can iterate or loop over our list without knowing anything about its internal implementation. So we can write code like this. While iterator has next, we're going to call iterator.next. This will return the current object. So we store it over here and then print it on the console. What's going on here? Well, imagine our list looks like this. So we have A, B, and C. This iterator is like a pointer that is pointing at one object. So initially it's pointing at the first object. At the beginning of our loop, we ask, do you have more items? It says yes. So here we call the next method. This will return the current item, which is the A, and then it will advance the pointer to point to B. In the next iteration, we ask the iterator, do you have more items? We still do. So this method will return true. Then we read the current item and advance the pointer. One more time, we read the C, and then the iterator ends up here. So in the next iteration, when we call the hasNext method, we'll get false. So this iterator is simply an object that we use to iterate over a list, or more accurately, an object that is iterable. Now, let me show you something really interesting. Let's compile the code. Then, from the project window, let's select the main class and look at its bytecode representation. Take a look. So over here, we have a reference to iterator.hasNext and iterator.next. Now, I'm going to delete all the code for using this iterator object and instead use a for each loop. So for each item in list, we're going to print each item. One more time, we're going to compile the code and look at the bytecode representation of the main class. Take a look. We still have a reference to the iterator object. So the for each loop is actually a syntactical sugar over the iterator object. When we use the for each loop, the Java compiler will convert our code to use an iterator object. This is the reason why we can iterate over this list using a for each loop. Now, if I remove this bit of code over here, implements iterable, and go back to the main class, you can see we have a compilation error saying for each not applicable to type generic list. So this is the benefit of implementing the iterable interface. It allows us to iterate over an object without knowing anything about its internal implementation. So I'm going to bring this back. Now, if tomorrow we decide to replace this array with, let's say, an array list, our for each loop is not going to get affected. Now, our implementation is not complete. We still have to implement the iterator method. And that's what we're going to do next. In this video, we're going to complete our implementation of the iterator method. So as you can see, this method returns an iterator object. This iterator is actually an interface declared in the java.util package. So here on the documentation, you can see the 4 methods declared in this interface. These 2 methods over here have a default implementation, so we don't have to worry about them. The only 2 methods that we have to implement are hasNext and next, which you saw in the last video. So now we should declare a new class that implements the iterator interface. So back to our generic list, we're going to implement this iterator as a private nested class inside this generator list class. You will see why in a second. So after the iterator method, we declare a private class called list iterator. This class should implement the iterator interface, which is generic. So iterator of t. Now this t that we have here is the same t that we used when declaring our generic list. So if the client of this class, let's say in our main method, we create a new generic list of string, this type parameter is going to be a string, and we're going to use the same type parameter over here because we're going to iterate over a list of strings. So that is why I don't want to hard code a type over here like string or integer. I want to use the same type parameter that we have on the top, okay? So here's our private class. Now let's implement the iterator interface. So we press Alt and Enter and select Implement Methods. So the 2 required methods are highlighted. Let's click OK. Now in this class, we want to iterate over a generic list. So we should pass that generic list over here via a constructor. So let's add a constructor, public list iterator. Here we need a parameter of type generic list of t. The same type parameter, we call it list. Now we should store this in a private field in this class. So private generic list of t, we call it list. And here we set this.list to list. Now, because we have declared this list iterator inside our generic list, here we have access to list.items. So we can see the items array. And this is perfectly fine because this class is part of the implementation of our generic list. So if tomorrow we decide to replace this array with, let's say, an array list, this class is the only place where we have to make changes because this class knows how to iterate over a generic list. So if we replace the items array with an array list, nowhere else in the code, nowhere inside the main method or anywhere else where we have used a generic list, we have to make changes, okay? Now, here's a question. How can we iterate over an array? Well, we need an index variable. Initially, we set it to 0. As long as the index is less than the number of items in the array, we increment it, right? So let's declare a private field of type integer called index. Now, in our hasNext method, instead of returning false, we're going to return a Boolean expression like this. If index is less than list.count. Then, in our next method, instead of returning null, we're going to return list.items of index, and then we'll increment the index. So initially index is 0. When we call the next method, this will return list.items of 0. Now, next time we call this method, index is going to be 1, so we'll return the second item in this array. And we're going to do this as long as index is less than the number of items in our list. Okay? So, pretty simple. We're done implementing our list iterator. Now, back to our iterator method. Instead of returning null, we're going to return a new list iterator. Now, note that here we have another list iterator, which is an interface declared in the java.util package. We don't want this one. We want the list iterator that we declared here. So let's create a new object. And here we should pass our generic list to the constructor of this class. What is that? That is the current object, this. So let's quickly recap. We made our generic list iterable by implementing the iterable interface. And here we return a list iterator. This is an object that knows how to iterate over a generic list. So it has intimate knowledge of the implementation detail of our generic list. If tomorrow we decide to replace this array with an array list or a different data structure, this iterator is the only place where we have to modify our code. Now, back to our main class. Let's add a couple of items in this list. Let's add A and then B. Here we can iterate over this list using a for each loop. Take a look. We get A and B. Next, we're going to talk about the collection interface. The next interface we're going to talk about is the collection interface, which represents an object that acts as a collection or a container for other objects. What are the operations that we need to work with a collection? We should be able to add an object to this collection. We should be able to remove an existing object. We should be able to check for the existence of an object and so on. These are the operations that the collection interface declares. Here on the documentation, you can see that the collection interface is also a generic interface because here we have a generic type parameter. But instead of T, we have E, which is short for element. That is a common convention for declaring interfaces or classes that have a collection semantic because a collection can have multiple elements, okay? Now, over here, you can see that this interface extends the iterable interface. So every collection is also iterable. And that means we can use a for each loop to iterate over all collections in Java. Now, over here, you can see various classes that implement this interface. As you can see, there are over 20 implementations of this interface. Most of the time, like 90% of the time, you only need to use the ArrayList class. These other implementations are for special purposes, and we're not going to cover them in this course. You can learn about them on your own. I just want to give you a strong foundation. So back to our project, I'm going to add a new package called collections. We're going to write all the code in this section in this package. I'm going to add a new class called collections demo. In this class, we're going to have a public static method called show. This is where I'm going to show you various operations in the collection interface. If you download the source code that I've included at the beginning of this course, you can see all examples in this class. But while I'm recording this video, I'm going to delete some of these examples to keep the screen clean and easy to read. Now, back in the main class, we're going to call collections demo dot show. Now, here I'm going to declare a variable of type collection of string. Let's import this type. So that is an interface. We call this variable collection. Now here we should set this to a new instance of ArrayList, because this is one of the classes that implements this interface. Now let's add a few items to this collection. So collection.add, we can add a string like A, then B, and then C. Because this collection is iterable, we can use a for each loop here. So for item in collection, we can print each item. So we get ABC. We can also print the collection as a whole. So print collection. Now, what if you want to add multiple items in one go instead of calling the add method 3 times? Well, here we have another class called collections. That is a utility class declared in the java.util package. This class has a method called addAll. The first parameter of this method is the collection that we want to modify. So we pass our collection over here. Now look at the second argument. Here we can see the list of parameters by pressing Command and P on Mac or Control and P on Windows. If this shortcut doesn't work for you, you can find it under View, Parameter Info. Okay. So look at the second parameter, a string ... When you see ... that means you can pass a variable number of arguments. You can pass 0 or more strings. So here we can pass A, and then B, and then C. So instead of calling the add method 3 times, we're passing multiple arguments to this method. Now, if we run our program, we get the same result as before. Another useful method is the size method that returns the size of a collection. So here we have 3 items. We also have a method for removing an object from a collection. So we can call collection.remove A, and then we can print the collection. So A is gone. We can also remove all items by calling the clear method. Now the collection is empty. We can verify that by calling the isEmpty method. So it returns true. If you want to check for the existence of an item, you can call the contains method. So we want to see if this collection contains an A. So it contains A, and then we can print contains A. We get true. There are times you want to convert a collection to a regular array. So here we call collection.toArray. As you can see, this method has 3 forms or 3 overloads. If you don't pass any arguments here, this will return an object array. So we can store it in an object array. So every item in this array is going to be an instance of the object class. That means if we get the first item and use the dot operator, we don't see any of the string methods. If that's what you need, then you need to convert this collection to a string array instead of an object array. That's very easy. We call collection.toArray. We're going to use this form, this overload that takes a T array. So if we pass a new string array here, now how many items do we have in this collection? 1, 2, 3. So we pass a string array over here, and this will return a string array. Also, we don't really have to specify the size here. We could simply pass 0, and that is a common convention because you don't want to worry about counting the number of items in your collection. You can simply pass an empty array, and this method would automatically create an array with enough capacity to hold all these items. Okay. Now, if we get the first item, we can access all the string methods. For example, we can convert the string to the lowercase or uppercase and so on. And by the way, we can use var here just as usual. Now, some people don't like var. They argue that we cannot see the type of this object, but that is not right. So if you put the caret over here and then go to View, Quick Documentation, the shortcut is F1, you can easily see that this is an object array. Or if you put the caret over here and one more time, press F1, we can see that this is a string array. So I personally prefer var because it makes our code cleaner. So this is how we can use the two array methods. Now, there are times you want to compare two collections for equality. So I'm going to create another collection of type string. Let's call it other and set it to a new array list. Now, what would happen if we use var over here? Then the type of this variable is going to be the ArrayList class, not the collection interface. So it's going to include the additional methods that are declared in the ArrayList class. Now, as I explained in the second part of this series, we should program against interfaces. This will make our applications more flexible and loosely coupled. So I'm going to revert this back to collection of string. Now, I want to add every object that we have in this collection in our second collection. So we type other that add all. Now look at the type of this parameter. It's collection of unknown extends string. So we have a wildcard again. That means we can pass a collection of string or any type that extends the collection of string. So I'm going to pass our first collection. Now, you want to check to see if these two collections are equal. So I'm going to do a print statement here. What do you think is the result of this expression? Collection equals other. Are we going to get true or false? We're going to get false because these are two different objects in memory. Look, here we have two new operations. So these are going to be different objects in memory. And this equality operator compares these objects by their references or their addresses in memory. Now, if you want to check to see if two collections have the exact same content, you should use the equals method. So print collection equals other. Take a look. So we get false as a result of evaluating this expression because these are two different objects in memory, but we get true because these two collections have the exact same content. So this was all about the collection interface. Once again, don't worry about memorizing any of these. All you need to take away from this video is the kind of operations that are provided by the collection interface. We can add an object, we can remove an object, we can check to see if an object exists, and so on. Don't worry about memorizing. You can always look at these operations on the documentation. Next, we're going to look at the list interface. The list interface represents an ordered collection, also called a sequence. So with lists, we can access objects by their index. In collections, we don't care about the index of objects. We just care about adding or removing them from a collection. So in your applications, if you want to work with an ordered collection, if you care about the index of objects in a collection, you should use the list interface. So let's declare a variable of type list of string. We're going to import this and set it to a new array list. Now, because the list interface extends the collection interface, here we have all the methods you learned about in the last video. So we can call list.add to add a few items, A, B, and C. But we also have an overload of the add that takes an integer. So if you want to insert a value or an object at a particular index, we use this overload. Let's say I want to add an exclamation mark at the beginning. So we pass 0 as the index of the first item. Now we can print the list. And here's the result. We couldn't do this with the collection interface because collections don't support indexing. Now we can also add multiple items in one go. So here we call collections that add all. Now look at the first parameter. It's a collection. So because every list is a collection, here we can pass our list object along with a few values like A, B, and C. Now here we can get an object by its index using the get method. So we can get the first item and print it, and we get A. We also have a method for replacing an object at the given index. So list.set Let's set the first object to A+. Now we print the entire list. And here's the result. We can also remove an object by its index. Here we call list.remove0. Again, we didn't have this method in the collection interface because collections don't support indexing. Now take a look. A is gone and we only have B and C. Another useful method is the index of method. So we can call the index of method and pass A, and this will return the index of the first occurrence of A. In this case, it's going to be 0. Now, if we search for a value or an object that doesn't exist here, we're going to get -1. There you go. Another useful method is last index of, and this will return the index of the last occurrence of this object. So if we add another A here, the index of the second A is going to be 3. So there you go. Now I'm going to remove this. Another useful method is the sublist method. So we can call list.sublist. Here we pass 2 indexes, from and to. From is inclusive, but to is exclusive. So we can start from index 0 and get all the items up to index 2. And this will return the objects at index 0 and 1. Take a look. There you go. Just realize that the original list is not affected because this method returns a new list, okay? So this is all about the list interface. Next, we're going to talk about sorting data. Thank you so much for watching this video. As I said, this video is part of my ultimate Java mastery course that teaches you everything you need to know about Java from the basics to more advanced concepts. So if you want to learn more, I highly encourage you to take a full course. It's much faster than jumping from one tutorial to another. If you're interested, the link is below this video. Thank you and have a great day.